In this video clip, we're going to talk about the example here. This example says that let polynomial p of x, which is given, is x cubed minus 4x squared minus 25, this one, be divided by the d of x, this one, d of x, which is x minus 5. Okay, now we need to do two things. One thing is to find out the quotient polynomial q of x. Another is to find out the remainder p of r of x. Okay. Now we may do the first step. We may find out the remainder first. Okay. We may find out remainder first by using the remainder theorem. By using the remainder theorem is that we may find out this remainder without doing the division. So that's the very powerful point for the remainder theorem is that we may find out the remainder without doing the division. It sounds impossible, but that's what remainder theorem says. By simply doing what? Simply plugging this 5 into here. Or you may say these two separate places. Okay. You see, you plug in 5 here, you get 5 cubed. You plug in 5 here, you get 5 squared. So then you have a 5 cubed is 125. And 4 times 25 is 100. And then minus 25. Okay. So we actually got 0. So from remainder theorem, it's quite fast to get the remainder without doing the division. And in this case, it's very special for our remainder, which is what? Which is 0. Remainder 0 is very special value. Okay. Now, we applied the remainder theorem to get remainder, but we may also using the synthetic division and the non-division to get our remainder here and here. Synthetic division is easier, so we may work on this one first. Okay. We have a 1, -4, 0, -25. Those numbers are from where? From here. You see, p of x is x cubed, means 1 times x cubed right here. And then minus 4x squared. There is no x10, so you may put 0 times x. And then minus 25. Here you can see it's 0. 0 times x is 0. This 10 was missing this one. So that's how you have a 1, -4, 0, -25 on these places. Alright. Okay. Now this my x minus 5, you want to put positive 5 here, not -5. Positive 5 here. Okay. So when copy it down, 1 times 5 gives you 5. Add together negative 4 with 5, you have a positive 1. Then 5 times 1, you have a 5 here, you put right here. 0 plus 5 is 5. And then 5 times this 5 again. So you have a 25 goes here. Add together, you then have what? You then have a 0 here. And that's the remainder, which is the one exactly we got here by remainder theorem. Then what's the quotient? The quotient, it was cubed. The degree was 3 for p of x. Now if you look at those three numbers, those three numbers, 1, 1, 5, then you will see one is you want to do is 1 times x squared. 1 degree down than the given polynomial. Another 1 times x squared. And then, not x squared. Another one is 1 times x. Going down. 1 times x squared, 1 times x. And then 5 is a constant. So this will be our quotient, which is exactly right here. So x squared. 1 times x is x squared, so you do not have to write 1. Okay, 1 times x is x, so you do not have to write 1 in front of x. And plus 5, that will be the remainder polynomial. That will be the quotient polynomial. Remainder polynomial is 0 already. We found it from here. For the long division, we may repeat quickly is what? You do plus 0x here again. Make sure that there is a spot for x. Okay. Then x squared times x is cubed, positive, but we put negative here. Negative 5 times x squared is negative 5x squared, but again we put positive opposite sign here is because we need upstairs minus downstairs. And then to cancel x cubed, we then get 5 minus 4, which is 1 in front of x squared. Okay. All right. So then we do is we want to eliminate x squared this time by putting x here. X times x is positive x squared. But again, we put negative sign. X times negative 5x is negative 5x, but again we put opposite sign here is because we want to do the subtraction. We cancel these two, so we have 5x down here. Okay, and then when you put constant 5 here, 5 times x is positive 5x. We do the subtraction, so we put negative. 5 times negative 5, we get negative 25. But again, we want opposite sign to do the subtraction. We got negative, negative is positive. And those two are actually cancelled, so we have a remainder is 0. Okay? So remainder is 0 everywhere through any of these three methods. And the quotient here is consistent with what we got right here. Okay? All right. I'll see you next time.